So non-synchronizable, as I said earlier, executed in sequence blocking style. So it because we have used our blocking statement. So for non-blocking it may change sometimes, but initial block is like initializing everything, so mostly it will go by sequence. Idle for testbench and stimulus. As you see in testbench we do some inputs, and we can use for forever block and for loop, so we can use inside this initial. So it is idle for testbench, and monitor display statements we can use here, and clock or reset generation also we can do that. So this is our first block. Second is our always block, which we will write logic for our all the logical blocks like combinational, sequential, and everything. We will go towards that in next slide. So firstly, it executes continuously during simulation whenever the sensitivity list is changes. So this inside this, whatever you have write is called sensitivity list, and whenever the sensitivity list changes, or whenever you are triggering statement, like here you can see in green, combination logic is write like a star, or you can give any variable name A or B. Star is used for writing all the variable. It will consider every input. Whenever the input changes, you can say you are always block will trigger, means execution will start from beginning. So whatever this procedural code is there, it will execute. And in sequential, if you write percentage or negate of clock, so whenever the clock is there and percentage of clock will there. Okay, I will take one example for that. So for example, this is our clock, and whenever this process is coming, so we will include this. For example, this is clock, so we will write this signal name is clock, and this signal is coming inside this our always block, this always block. So whenever this process is coming, it will execute. So this is the logic. So what happens if we write only always and not write anything at the rate? So this is the statement will execute. It will not give compilation error, means if you don't use this part and only execute this and rest of the code. So what happens is your simulation will get hang, or you say it will having so much things to execute, it will get stuck somewhere, or you can say we cannot execute this much of simulation. It will continuously going on, it will not stop. And even in $finish also, for example, if it is going 1 nanosecond, 2 nanosecond, 3 nanosecond every triggering. But what happens in always block, in between 1 and 2 there is also a infinite number of points, so this will execute. So for example, if $finish is at 3 nanoseconds, so it has so many points from 1 to 2, it gets stuck there and it keeps executing that same thing. So don't use always block without any triggering statement. System Verilog has some more concept in that, and they have include always com and always block, some varieties of always block. So we will see when we will have our System Verilog course. So first, always block has two type of execution, as I said, sequential and combination block. So for example, if multiplexer, or that is 2:1 multiplexer logic you are writing inside your code, so and I have already created simple videos for our normal circuit, so you can watch that rest of the code like module and everything. But for now, you can say the always block is the main logical block. So this is our conditional statement if and else, and you can execute this with the help of always block. Here it is used star, so whenever the select or A or B are changes, it will execute. And we are using this type of statement for combinational circuit, and for sequential circuit we are using process of clock and process of reset. So this is asynchronous because asynchronous reset is coming without a synchronization of our clock. So